Hello dear students. Today we will continue with the RS system of nomenclature. That is the part 3. So here we will try to learn some new concept. Okay, basically not new. Today we will talk how to assign the R and S configuration in wedge and dash projection. Earlier we have discussed about that how we can assign the R and S projection in R and S configuration in Fisher projection. Okay, so basically today we will discuss about the wedge and dash projection. So let us see what is that wedge and dash projection. So sometime you will be able to see the structure like this. Okay, you will be able to see a compound like this, and it will have the bond that is called the dash bond, and another one, it is it will be like this. So this is called the wedge bond. Definitely this is the center, so there will be a carbon, so this will be okay, like that. So sometime you will be able to see the structure like that. So this is called wedge and dash. This is the wedge and this is the dash. So why it is called wedge and dash? Because of these bond, the wedge bond and dash bond. So why it is drawn like that? What is meaning of that? Okay, so when we will see a 3D structure of any molecule, so we will be able to see that what is this wedge and what is this dash. So basically the dash means the group which is attached in with this dash bond, it will be below the plane, below the plane, or you can say away from the viewer, right? Wedge means, or the group which is attached with wedge bond, it will represent the group is above the plane. Okay, it means above the plane, or towards toward the viewer. Okay, so let me show you by this picture, it would be clear to you. So this is the structure of any molecule. So basically it is the chiral carbon, the carbon in center. Why it is chiral? Because it have four different groups. See, bromine, iodine, chlorine, chlorine. So in 3D structure or structure in space, if you will see, you will be able to understand what is the meaning of that, away from the viewer and towards the viewer. If you observe this structure, you will find that these two, this red one and pink one, they are in one plane. Okay, they are in one plane. What about these two? See, this is the fluorescent one and yellow one. See this. See, in this way, this yellow one is coming towards me as I am the viewer, and the fluorescent one is going away from me, that is away from the viewer. To, so yellow one towards the viewer, it means it is coming towards me, and this fluorescent one, it is going away from me. So this is the structure away from the viewer. It will be always represent by the dash bond, and the one which is coming towards me, this one, this yellow one, we will draw it, or we will assign, or we will draw it by the wedge bond. Now I hope it would be clear to you. See, if you see the structure like that. See. Okay, so any structure, any molecule, it can be away from the viewer, or here you can also understand in this way. Now this one is coming towards me, and that one is going away from my side. So by this, I hope it is clear now. So now we will see how to write that structure correctly. So see, this one, the lower, or the group hydrogen, it is in dash bond. Okay, it means this is away from the viewer. It is going away from me, and the bromine, it is in wedge. So it would be towards the viewer, or you can also say above the plane, below the plane. Okay, so now we will learn that how to draw that projection. This is the wedge and dash projection. It is not like you can draw in as such, like in wrong pattern. Okay, let me tell you what would be the right one, what would be the wrong one. If, what is this? This is internal angle. Internal angle. This is the external angle. So whenever you will draw the wedge and dash projection, this wedge bond and dash bond, it will be always in external angle. You will not draw this wedge and dash in internal angle, right? So if you will draw the structure like this will be the wrong. Okay, wrong one. What would be the right one? Okay, so this would be internal, and this is the external side. So here you can draw, whether you can draw the wedge here or dash here. So now I hope you understood how to draw the wedge and dash projection. Now we will see how to assign the configuration, whether it will be R or S in wedge and dash projection. So I will tell you the rule. As we have discussed in word in that Fisher projection, what we were doing, that least priority group must be in vertical. Okay, whether it can be here or here. So what we were doing, if it is R, we will write R. Okay, but if this fourth group or least priority group, it is in horizontal, so what we were doing, if it is R, we were inverting it. If it is S, we will have to revert it to the R. R will revert to the S, and S will be written as R. This will be similar here, but the difference would be, see, this is one plane, this is the dash, this is wedge. Now we have to assign the configuration. So better to have one example here. Okay, so with that it would be easier. So let me draw the structure of that. See. Okay, just give it the number 1, 2, 3, 4. After assigning the number, after assigning the priority, we will see the compound like that. So what we will have to do? We will have to move 1 to 2, 2 to 3. So how we are moving? Clockwise. So clockwise will be R. If it is anti-clockwise, so it will be S. Up to this it is clear. Anti-clockwise S. Now we will have to see the fourth group. The rule says the fourth group or least priority group, it must be in dash bond. So if it is in dash bond, the configuration, whatever the configuration will be there, suppose it is R, as you can see here, the fourth group is in dash. So it is clockwise, so we will write it R only. Okay, now if it is not in dash, or suppose fourth group is not in the dash, so what we will have to do, suppose here group 3, fourth group is in wedge, as we were seeing in that vertical or horizontal. So in that case what we will have to do, 1 to 2, we have to move 1 to 2, 2 to 3. But what we are observing here, the fourth group is not in dash, it is in wedge. So it is moving the clockwise, so it will be R, but as the fourth group is in wedge, it is not in dash. So what we will have to do? We will have to write it F. Okay, so it is very easy, like we have already done in case of the Fisher projection. Now this was the condition if the fourth group is in dash or wedge. So what we will have to do, if fourth group is in dash, as such we will write R to R, S to S. If the fourth group is in wedge, we will have to invert it. Now suppose this fourth group is at 2 position. So what we will have to do? Okay, suppose this is not in above the plane, below the plane, or away from the viewer, towards the viewer. It is not there. It is in different plane, that at 1 or 2. So in that case, okay, let me draw that. The group, this is wedge, this is dash. So here, the fourth group, suppose here, it is 1, it will be 2, 3. In that case, we will have to apply the exchange rule. So what is that exchange rule? We'll see. Exchange means we have to interchange the group. So in that case, if it is not in dash bond, or wedge bond, in that case what we will have to do? We will have to do even exchange. Even exchange. It means we have to do two-time exchange. Exchange is also two types. Odd exchange. Odd exchange. Here you will do one-time exchange. Okay. So now let us discuss it with an example. So see this example. Okay. Chlorine, fluorine, iodine, and here it is bromine. As you can see, the least priority. This is the first priority. This is second, as per the atomic number. This is the third. This is fourth. Now what we will have to do? We will have to apply the exchange rule. So how we will apply the exchange rule? That first we will have to do the two-time exchange. So first time we will have to do the change, that would be the first change, or that would be the odd change, odd exchange. In that, what we will have to do? First, we will exchange this. We will bring this chlorine here and that chlorine here. In that case, what it will be look like? How it will look like? It will look like this. This is the chlorine. Chlorine coming here, fluorine coming to this place. We are not going to do anything with this. It will remain as such. Iodine, bromine. Okay. So 1, now 4, this is 3, this is 2. This is the odd exchange. We made here first change, first time. Now second exchange, second one, it will be even change or even exchange. So now first we exchange this to this. Now what we will have to do? We have to exchange this chlorine with this iodine. So as here we made first exchange by chlorine to fluorine, fluorine to chlorine. Now fluorine is here. Now we will do the second change. With this, fluorine will come here, iodine will come here. So what structure you will get? Iodine, chlorine, and this will be the fluorine, and it will remain same. So here now you can see this iodine priority 1, fluorine 3, bromine 2, fluorine 4. Now you can see the fourth group is in dash bond. So what we will have to do now? We have to move 1 to 2, 2 to 3. We cannot move like that. 1 to 2, then 2 to 3. No, it would be wrong. 1 to 2, 2 to 3. How it is? How it is moving? Anti-clockwise. So the carbon here, okay, that would be in the configuration, the chiral carbon. Chiral, the configuration of that carbon would be, as it is moving anti-clockwise, it will be S. See this, fluorine is in dash. If after rotation that fluorine is coming in that wedge, so what we will have to do? We will have to invert it, S to R or R to S. But now this fluorine is in dash bond, so what we will do? We will write as such what it is there. Okay, so I hope now you understood the concept behind that, how to do the nomenclature, or how to assign the configuration R or S to that in wedge and dash configuration. Okay, so I hope this will help you to assign the configuration in various organic molecule. So if you think the video is helpful for the pharmaceutical organic chemistry students, if you like, share and subscribe, so other students will also get benefit.